Problem 9. This is a problem from quantum mechanics. The question is, spin half fermions of mass m and 4m are in a harmonic potential V of x, which is equal to half kx square. Which configuration of 4 such particles has the lowest value of ground state energy? Option A, 4 particles of mass m. Option B, 4 particles of mass 4m. Option C, 1 particle of mass m and 3 particles of mass 4m. And option D, 2 particles of mass m and 2 particles of mass 4m. The question is asked in NET June 2020. Here, harmonic potential is given, half kx square. And we have to fill 4 particles. Then, which configuration has the lowest value of ground state energy, which we need to find out. So let us draw the harmonic potential in each case corresponding to each option. Let us draw the harmonic oscillator potential half kx square. And let us draw the energy level diagram, and then let us fill the particles. Now here you have to consider this fact. We have omega is equal to root k by m. Now when the mass changes to 4m, what happens to omega? Omega changes to omega by 2. So you have to consider these things while drawing the energy level diagram. Now in first case, option A, all 4 particles has mass m. First let us draw the energy level diagram for harmonic oscillator with a mass m. For a particle of mass m in a harmonic oscillator potential, the lowest energy is half h cross omega and the next energy is 3 by 2 h cross omega. Now you have to fill the 4 particles of mass m here. Now this corresponding to 2 particles in the energy level half h cross omega and 2 particles in the energy level 3 by 2 h cross omega. Now how the filling is done? Here you have to use the degeneracy. Degeneracy is given by 2s plus 1 and the particles are spin half fermions. So when you substitute the value of s is equal to half, your g become 2. That is, a single energy level can accommodate 2 particles. So what is the total energy or ground state energy of this configuration, which is nothing but 2 into half h cross omega plus 2 into 3 by 2 h cross omega, which is nothing but 4 h cross omega. That is corresponding to option A, the ground state energy is 4 h cross omega. Now let us see option B, 4 particles of mass 4m. Here, as I specified, the mass is changing to 4m, so omega is changing to omega by 2. So your energy levels become, instead of half h cross omega, you have h cross omega by 4, and instead of 3 by 2 h cross omega, you have 3 by 4 h cross omega. So the energy levels are represented as half h cross omega and 3 by 4 h cross omega. Now you have to fill the 4 particles. So 2 particles will be in half h cross omega energy level, and for other 2 particles the energy will be 3 by 4 h cross omega. So the ground state energy for option B is 2 into half 1 by 4 h cross omega, 2 into 1 by 4 h cross omega plus 2 into 3 by 4 h cross omega which is nothing but h cross omega by 2 plus 3 by 2 h cross omega, which is equal to 2 h cross omega. So corresponding to option B, the energy of the ground state, which is 2h cross omega. When you fill 4 particles of mass 4m in half kx square potential, the energy will be, the ground state energy will be 2h cross omega. Now in option C, you have 1 particle of mass m and 3 particles of mass 4m. See, the energy of 1 particle of mass m, that is nothing but half h cross omega, whereas you have 3 particles of mass 4m. Now out of the 3 particle, 2 particle will occupy, or 2 particle will have the energy 1 by 4 h cross omega, and the remaining 1 particle has the energy 3 by 4 h cross omega. So you have the energy level diagrams, which is shown in column C. Now let us write the value of energy, which is 1 by 4 h cross omega, 1 by 2 h cross omega, then you have 3 by 4 h cross omega, and then again 3 by 2 h cross omega. Now let us fill the particle of mass 3m first. The mass 4m first. Now out of the 3 particles of mass 4m, 2 particles will occupy in the level half 1 by 4 h cross omega, and 1 particle in 3 by 4 h cross omega, and the particle of mass m has the energy corresponding to half h cross omega. So the total energy will be 2 into 1 by 4 h cross omega plus 1 into 1 by 2 h cross omega plus 1 into 3 by 4 h cross omega, which is nothing but 7 by 4 h cross omega. Now let us check the option D. In D, you have 2 particles of mass m and 2 particles of mass 4m. These 2 particles of mass m will have the energy half h cross omega, and 2 particles of mass 4m will have the energy 1 by 4 h cross omega. So first let us fill the 2 particles of mass 4m on the lowest energy 1 by 4 h cross omega. Then in the 1 by 2 h cross omega level, you have another 2 particles having mass m. Here the ground state energy is nothing but 2 into 1 by 4 h cross omega plus 2 into 1 by 2 h cross omega, which is nothing but 1 by 2 h cross omega plus h cross omega, which is nothing but 3 by 2 h cross omega.